In this video, we're going to talk about solving systems of two linear equations using the graphical method. Now, I've written a system of equations right here, and the question is, how do we solve this using the graphical method? Now, remember, to solve it means to find an ordered pair, x comma y, that makes both of these equations true. Okay, so what do we mean by the graphical method? Well, we're going to try to graph each of these equations. Okay, now how do we graph x plus y equals 4? There's a couple ways to do it. One way, though, is to get it in the form y equals mx plus b, and you do that by subtracting x from both sides. If you subtract x from both sides, you get y equals negative x plus 4. Okay, so the slope is -1, the y-intercept is 4. And in this equation, we can add 2x to both sides, and we would get y equals 2x plus 1. Okay, so what we want to do is graph each of these equations. Now, y equals negative x plus 4, that goes through the y-axis at 4. The y-intercept is 4. The slope is -1, meaning if you go over 1, you go down 1, over 1, down 1, over 1, down 1, and so on. Okay, so y equals negative x plus 4 is going to be this line. Draw a little better here. Okay, and y equals 2x plus 1 is going to have a y-intercept of 1 and a slope of 2, meaning if you go over 1, you'll go up 2. If you go over 1 more again, you'll go up 2 again. Likewise, if you went back 1, you would go down 2. But y equals 2x plus 1 looks like this. Okay, now we've graphed both these equations. What does it mean to say that we've graphed them? Well, y equals 2x plus 1, there's a whole bunch of points on this line. All of those points are ordered pairs that would make y equals 2x plus 1 true. Okay, all of the points on this line are ordered pairs that would make y equals negative x plus 4 true. Okay, that's what it means to graph an equation. So are there any points that make both equations true? Well, yes, this point right here makes both equations true, and I think you can see this point is the ordered pair 1, 3. So 1, 3 is the solution of this system of equations. You can check for yourself. If you plug in 1 for x and 3 for y, both of these equations will be true. Okay, so that's what it means to solve a system of equations using the graphical method. Now, I should say there are some limitations to this method. One limitation is that sometimes it's not so clear where the 2 points intersect. Our points intersected at coordinates that were nice whole numbers, but it could be that they intersect at a point 1.7, 3.5, and it's very hard to see that it's exactly going to be that, just kind of eyeballing it. Okay, so this method does have some limitations. We'll see a couple other methods to solve systems of equations later. Okay, now I also want to point out that there are really 3 possibilities when graphing two linear equations. 3 situations could happen. One of them is one where we just saw the 2 lines could intersect each other at a single point. Okay, so that situation looks like this. You have 2 lines that intersect each other at a single point. Okay, so there's one solution. Okay, another possibility, though, is that you could have parallel lines. Okay, so there are no solutions. So no solutions. They are parallel. And the final possibility is that when you graph the 2 lines, you could get the same line 2 different times. Okay, so this would be infinitely many solutions. Okay, this would be the same line. If you graph both equations, they gave you the same line, then any point on this line would be a solution to both equations. Now, to say there are infinitely many solutions, it does not mean that any old ordered pair would be a solution. For example, a point way up here that's not on that line would not be a solution, but any point that's on these lines here would be a solution. Okay, now a system that has a solution is said to be consistent. Okay, so this one right here, okay, this second scenario is inconsistent. Okay, this one is inconsistent because it does not have a solution. Okay, and the last one is also a special case. When you have the same line, you say these lines are dependent. Okay, the other ones are independent, but these are the same lines, so they're dependent. So that's just some terminology that we use.